Okay, grade 12, I'm going to look at some exam type questions around sequence and series. Okay, sequence and series is your guys' first topic that you are doing in grade 12. And so as you are going to be doing that topic, it becomes very important for you guys to be able to know how to solve geometric, arithmetic, and quadratic sequence type questions. All right. You are all welcome to the grade 12 live lesson for sequence and series, right? Guys, if you guys want to get into the content around sequence and series, then I would really encourage you guys to visit my YouTube channel with my last year's videos that I posted of the lessons for sequence and series. I would encourage you to do that. What I want to do right now is to actually look at like exam type questions around sequence and series. Hopefully by doing that, we can cover some ground as far as some of the concepts underlying sequence and series, because I don't want right now to teach sequence and series, but I will be teaching sequence and series through the exam problems or the exam type problems that I will be answering. Okay, so hopefully you guys get my point, and we do not lose sight of what I'm going to be doing today. So basically that's what I'll be doing today. Otherwise, hello grade 12s, I hope you guys are well. Please tap very hard on the screen. Like, don't tap too hard that it breaks your phone, but tap enough at least so that we can get the likes a little bit above the threshold. 420 likes is good, but I think we can definitely get it to be more likes. Hopefully people were able to join my session yesterday. If you missed it, then I uploaded the lesson that I did yesterday on geometric sequence onto the channel, so you can check it out. Okay, so in summary, guys, in grade 12 you guys are looking at under sequence and series, you are looking at 3 types of number patterns. The first one is your quadratic. You guys did quadratic sequence in grade 11. All right. Then you are also looking at arithmetic. And then lastly, you look at geometric. So these are the types of sequences you are looking at. Quadratic, you guys know, adopts the quadratic form of the sequence. Arithmetic you guys did linear patterns in grade 10 and in grade 9, but then arithmetic pattern is somewhat of a linear pattern, if you want to call it that, and the general term is Tn is equal to a plus brackets n minus 1 d. Then with your geometric sequence, you have Tn is equal to ar to the power n minus 1. Okay, so Your quadratic sequence, you guys learned in grade 11 that generally speaking, your original sequence in terms of A, B, and C, okay, you have A plus B plus C, right? Which is your first term, because if you substitute 1 in the place of n, you get A here. You substitute 1 in the place of n here, you get B. Then you substitute, there's no 1 there, so it's A plus B plus C. And then imagine if you substitute 2, you get the same thing. You substitute 3, you get something quite different. So if you substitute 2, you are going to get 4A plus 2B plus C. That would be your second term of the original sequence. Merry Christmas to you too. Merry Christmas, maths. Okay. And then your third term, T3, would be 9A plus 3B plus C. All right. So generally speaking, that's your quadratic sequence in terms of A, B, and C, if we are looking at term 1, term 2, and term 3. Okay. Then if you then look at the first difference of your quadratic sequence, that means you are going to take term 2 and subtract term 1. What happens? What's 4A minus A? That gives you 3A. What's 2B minus B? That gives you positive B. And then what is C minus C? That gives you 0. Let's go and subtract term 3, term 2 from term 3. 9A minus 4A, that gives you 5A. 3B minus 2B, that gives you positive B. And then C minus C gives you 0. If you look at your second difference, you know that your second difference is going to give you a constant expression of 2A. Even if we had the next second difference term, your third term in your second difference, you would get a constant second difference of 2A. All right. And these generally or basically are the three expressions you use in a quadratic number pattern in order to get the general term. So this is the original sequence in terms of A, B, and C. This is your first difference, which, mind you, is actually an arithmetic sequence or a linear sequence. Your first difference for your quadratic number pattern is an arithmetic sequence. Then you have your second difference, which is always constant, which it gives you 2A. All right, and these are the expressions you use to basically calculate the value of A, calculate the value of B, and calculate the value of C. Rest, my king. Thank you for calling me king, but resting, not going to happen. All right, okay. All right, so that's quadratic sequence. I think someone earlier on said, can you help me out with geometric sequence? All right, so this is important. All right, if we go to arithmetic sequence, guys, we know most. Okay, so basically the definition here of a quadratic sequence would be a sequence whose second difference is constant. That is what a quadratic sequence is. Guys, please if you are in the comment section and you're coming in and you're really like feeling like this guy needs to rest, let's leave the maths alone for now. Guys, just please, you can go on to the next live. Don't stick around. Okay, I'm afraid that it's going to give you PTSD. I don't want you to have PTSD before Christmas. Please, 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 please. Okay. Then we have your arithmetic sequence, guys. Arithmetic sequence. Okay, if we look at the original sequence in terms of, if we substitute 1 here and we figure out what the first term 1 is, you substitute 1 here, you substitute 1 there. What's 1 minus 1? It's 0. 0 times D gives you 0. You are left with A. So that means term 1 is A. Term 2, you substitute 2 here. 2 minus 1 gives you 1. 1 times D is D. A plus, you get A plus D for term 2. Term 3, you substitute in the place of N3, which is for the position. You substitute in the place of N3. 3 minus 1 is 2. What's 2 times D? 2D. So you have A plus 2D. That's term 3. And I mean, we can go on, guys. Okay. But let's notice something. So that's my original sequence in terms of A and D. Then my first difference, A plus D minus A. Remember, we are going to say A minus A, which is 0. Then we're left with D. Let's move on to third term minus second term. A minus A is 0. 2D minus D is D. So we have a first difference here that is constant. So I just want to recap again. For your quadratic sequence, our first difference gave us a arithmetic sequence. But then the second difference is constant. For what? For a quadratic sequence. Okay. Arithmetic, on the other hand, sequence. This is our general term of an arithmetic sequence. Our original sequence in terms of A and D. Term 1 gives us A, term 2 gives us A plus D, and term 3 gives us A plus 2D. Now, when we subtract or we find the first difference, we notice that the first difference is actually constant. Because what do we get here? D and D. There's no second difference, there's only a first difference. And the first difference is what? It's constant. So an arithmetic sequence is simply what? By definition. An arithmetic sequence is a sequence whose first difference is constant. So in an arithmetic sequence, the first difference is constant because you can see there, your first difference row has D and D. Okay, so that's just to kind of help summarize the concept of arithmetic sequence. Okay, then if we go to geometry, guys, geometric sequence, simply put, a geometric sequence, if we were to write down the original sequence in terms of A and R, we substitute 1 in the place of N to get term 1. That means T1 is equal to, we substitute 1 in the place of N. What's 1 minus 1? We get term 1 is AR to the power 0. R here stands for constant ratio. Landlord, can you please leave the live? Okay, I'm gonna block all the people that keep on sending funny messages here. Okay, I'm gonna block you guys. I'm sorry, unfortunately. You guys starting to get a little bit on my nerve. So unfortunately, you signed up for this, so I'm going to really get rid of you guys. Okay. Okay, I'm allowing you to enjoy your Christmas in peace. You don't have to stay in the live. You can just leave the live. Okay. You can just simply leave the live. So like I said, guys, this is just, I'm still recapping on sequences, the different types of sequences that you guys have to know in grade 12. I have not touched a series at all. Okay, yeah. All right, so just for now, hang tight on sequence, and then when I convert or when I change my gears, okay, and then I go through geometric arithmetic series, then I will actually notify you of that. Okay, so for now, if we are to write down the original sequence in terms of A and R for a geometric sequence, what we simply do is we go to the general term. Tn is equal to AR to the power n minus 1. Remember, your A, just like here, your A for arithmetic and geometric is simply what we call the first term. So for your GS, meaning your geometric sequence, and your AS, your arithmetic sequence, A means first term. D for your arithmetic sequence means constant difference, whereas R in your geometric sequence means constant ratio. All right, so that's just something you need to note. But for now, I'm saying that if you take Tn for your geometric, you find the first term of your geometric sequence. Substitute 1 here, 1 in the place of n. You mean that you're going to have 1 minus 1 there. So that will give me AR to the power 0. Okay, AR to the power what? 0. Now AR to the power 0, guys, simply means A times 1, which is A. So that's why the first term, you remember I said the first term for a geometric sequence and your arithmetic sequence is simply what? It's represented by the letter A. A here for your arithmetic sequence is the first term. As you can see here, A is the first term. Then for your geometric sequence as well, you substitute T1 in the place of Tn. In the place of n, you substitute 1. You get there for your exponent 1 minus 1. What's 1 minus 1? It is 0. What's AR to the power 0? It simply gives us A. That's our first term of a geometric sequence in terms of A and R. Written fully, it would be AR to the power 0. But we just simply write it as A. Okay, moving right along. Term 2 would be AR. Now in the place of n, you would write in the place of n 2 minus 1. What's 2 minus 1? That leaves us with AR to the power 1. So term 2 is AR in terms of A and R. What about term 3? Term 3, you substitute 3 in the place of n. 3 minus 1 gives you 2. So term 3 is AR squared. Okay. So yeah. Then you guys are funny. You act as if you don't have a choice. Leave the live. Guys, can I just ask you kindly? Leave the live if you don't want to be here. If you feel harassed by the live, leave. Please, guys, leave. Don't comment in the comment section, because if you do, I'm going to mute you and then I'm going to block you. All right? So leave the live rather. Okay, keep your emotions to yourself and then leave the live. That way you save me and you the trouble. All right? You might feel harassed by the fact that I'm doing the live. It's Christmas Eve. Okay? Yeah, it's funny that it's a day when apparently gifts are supposed to come. I am gifting you mathematics. If you don't feel that it's a worthy gift for you, leave the live. It's as simple as that. But do not comment in the comment section. I'm going to block you. Okay? I'm going to block you. If you comment something that basically, I'm going to block each and every one of the people that comment in a way that is unacceptable, I'm going to block you. So AR to the power 0, that's A. So the first term is A. The second term is AR. The third term is AR squared. So these are the terms of our geometric sequence in terms of A and R. All right, does that make sense? So guys, please, this is important. Now, furthermore, if we write down the definition, let's check for a moment here. You may notice something a little bit different now with this particular sequence for your geometric sequence. I'm not going to look for a difference between the terms. Rather, I'm going to look for the ratio between the terms. Okay, the ratio, in other words, AR divided by A. So if you were to write down what AR divided by A is, okay, this is AR divided by A, term 2 divided by term 1. That would mean the A and the A cancels out. What are you left with? R. So we are multiplying by R to get the next term. Let's look at term 3 divided by term 2. That means AR squared divided by AR. So that means you are going to divide A and A. A divided by A gives you 1. Then R2 divided by R to the power 1. That means 2 minus 1. So the answer is R again. So that means we are multiplying by a particular, what do we call it? Constant ratio. Constant ratio. So that's why we say R is what we call the constant ratio. All right. A, just like A here, is the first term of our sequence. D here is the constant difference, the first constant difference, because it's the second term minus the first term together with the third term minus the second term. That gives us a common constant value. Whereas for a geometric sequence, for our given sequence in terms of A and R, we are talking about a ratio between the terms. AR divided by A, AR squared divided by AR. That gives us R, the constant ratio. So when we talk about a geometric sequence, we are saying that the definition of a geometric sequence is that it is a sequence whose ratio is constant. It is a what? A sequence whose ratio is constant. Okay, so I hope that makes sense. A sequence whose ratio is constant. That is what a geometric sequence is in essence. Okay, so slowly but surely we take this in. All right, we take this in. Of course, we're gonna go look at examples, guys. Okay, we're gonna look at examples, but you guys need to just calm down a bit. Calm down. Now, that is what a sequence is. Okay, a series. Okay, a series is a different situation altogether, because a sequence is simply a list of ordered numbers. Okay, I don't understand what Gamma X is saying. Sorry, but how did we move from AR to XR? Who talked about XR? I'm baffled. Okay, what is it exactly? Where is the X? A times R gives you AR. AR times, this is multiplication. So A times this gives you that. AR times the R gives you R squared. All right. So this is just basically how we are getting the next and the next term. In order to get the next term, we have to multiply by the constant ratio where a geometric sequence is concerned. Guys, I'm just simply explaining your geometric sequence from the stance of your general term. This is a general term of a geometric sequence. It's Tn is equal to AR to the power n minus 1. I told you that you can generate the terms of the geometric sequence by simply substituting in the place of n. Remember, n means position. So if you are saying T1, substitute 1 here. What do you get? 1 minus 1 gives you 0. So you get an AR to the power 0, which is your first term. That's term 1. But remember, R to the power 0 gives you 1. So A times 1 is A. That's your first term in your geometric sequence. If you want to get the second term of your geometric sequence, simply substitute 2 in the place of n. You get AR to the power 2 minus 1. What's 2 minus 1, guys? It is 1. So you get AR to the power 1. This is your second term for your geometric sequence. You want to get the third term of this geometric sequence. You substitute 3 in the place of n. AR to the power 3 minus 1. What's 3 minus 1? It's 2. So your first, second, and third term are simply generated in this way. That's how you get your terms of the geometric sequence in terms of A and R. First term is A, second term is AR, third term is AR squared. I'm sure you guys know what the fourth term would be. What would be the fourth term in terms of A and R? If term 1 is A, term 2 is AR, term 3 is AR squared, what is term 4 of the geometric sequence in terms of A and R? What is term 4 in terms of A and R? In the comment section, you guys can populate. At least maybe you can answer that. Avamotiwa, thank you so much. It's AR to the power 3. AR to the power 3. AR to the power 3. Thank you, Nopinki. Thank you so much. Term 5 of the geometric sequence, what would it be in terms of A and R? Term 5. What would be term 5? You could almost say we are actually busy with term 5 at the moment. You guys, this year, you had term 1 of school, term 2, term 3, term 4. Now you are busy with term 5 of your academics with me on Christmas Eve. How do you like that? Yes, guys. AR to the power 4, that's term 5. What about term 28? What would be term 28 in terms of A and R? Term 28. Please help me out there. Term 28 would be what? What would be term 28? Okay, VKV, B, F boys. AR to the power 27, no Lu, Ava, no Pinky. Thank you so much. You guys, you get the point. Term 28 would be AR to the power 27. Precious, thank you so much. So you guys are getting the point. Okay, you get the point very loud and clear that in terms of A and R, this is how we generate our terms. Now, simply put, okay, you notice then that in order to get the next and the next term, there is a constant ratio that we are multiplying by. What is it? It is R. How did we get it? We took term 2 and we divided it by term 1 and we found that we get R. We take term 3 divided by term 2, we get R. So this is what we've multiplied. We took term 1, multiplied by the constant ratio, we get term 2. We take term 2, multiplied by the constant ratio, we get term 3. We take term 3, multiplied by the constant ratio, we get term 4, and so it goes. So this here is not x, it is multiply. We multiply by R throughout. That is what we call the constant ratio. Guys, ratio, the word itself, Okay, this here, let's say I had 5:8. This is what we call a ratio. A ratio is a comparison between two quantities of the same type. This same ratio can be written as a fraction, 5/8. These two mean the same thing. That's why we call this a rational number, because it is comprising what we call a ratio, rational, a number that can be written as a fraction where the numerator and the denominator are integers. So the ratio is constant. T2 divided by T1 gives us this constant ratio. T3 divided by T2 gives us this constant ratio. So that's why we say a geometric sequence is a sequence whose ratio is constant. Okay, I would say whose first ratio is constant. I hope it makes sense now. Okay, so that those who are asking questions about times and a and x, I hope that clarifies that, because I did not quite understand how to address that particular concern, but I think I did justice in explaining again. Arithmetic sequence, this is the general term. T1, you substitute term 1, you get a plus 1 minus 1, you multiply it with t. This here will give you 0 times d, which leaves you with just a. That's term 1 of your arithmetic sequence. Term 2 of your arithmetic sequence, you substitute in the place of n 2. Then you have 2 minus 1. That gives you 1 times d, so you have a plus d. That's term 2. Term 3, T3, you substitute in the place of n 3. 3 minus 1 gives you 2. 2 times d is 2d. You have a plus 2d. That's term 3 of your arithmetic sequence. So you have term 1, that's a, term 2, a plus d, term 3, a plus 2d. Can you guys tell me what the fourth term is for your arithmetic sequence in terms of a and d? Nolu, is it compulsory to use this formula for arithmetic instead of t is equal to dn plus c? Noli, which grade are you in? Are you in grade 11 or are you in grade 12? That's my question to you. First answer that question. Then after that, I can address you. Avamotiba, a plus 3d. Term 4 is going to be a plus 3d. Thank you very much. Nolu, you are in grade 12. Then please familiarize yourself with this baby. Okay? Get familiarized with this baby. It's not wrong to use what we have spoken about, but please familiarize yourself with this baby and start flowing with this baby before schools reopen, so that when you go back to school, you can flow very nicely in this little baby that we have there. You know that this is a linear general term. dn plus c is what you've been using for grade 10, grade 9. But now you are in grade 12 and you are being exposed to a little bit more. So utilize it, okay? Utilize it. It's your time to shine. So term 27. Can you guys tell me what term 27 would be in terms of A and D in the comment section? In terms of A and D, what is term 27? Term 27, guys. Just term 27. I want to know in terms of A and D, what is term 27? You can just give it to me. I'll be very happy in the comment section. Kulekani Ndlovu, thank you. A plus 26D. No ping, A plus 26D. Cruise, you are cruising there. Precious, you are so precious. Ava, you are aviating everywhere. Nolu, thank you so much. Classic Fresh, you are classic indeed. So all in all, guys, you guys get the point. Always one less than the term number that we are talking about. If I say term 27, then obviously next to D, we are going to have 26. One less than 27. All right, just like with the exponent here, if I say term 27, we are always going to have an exponent that is one less than the term you are referring to. So you guys are getting the point. okay, for your arithmetic and your geometric sequence. And of course, guys, quadratic, you guys know, you know very well. Okay, let's take it in. Okay, before I actually step into this world of series. All right, before I step into the world of series. Take it in, breathe in, breathe out, breathe in, breathe out. Hopefully you're breathing, getting that oxygen to oxygenate whatever, do whatever it needs to do. Okay, it's very important, very, very important. Oxygen, get it in there. So if you have any particular questions, this would be a good time before I step into I leave sequence and I step into series. And I almost feel like I need to first look at geometric series, because I don't know how many times I've been, like yesterday in the live, people were harassing me about geometric series. Today, be very early when I was jumping into this thing, people were still asking me about geometric series. It seems like geometric series is the one thing that is harassing you guys. Okay, is that true? True story? True or false? Artie is like, it's true. Artie, you are funny. Artie, you are funny. Okay, guys, both, ne? All right. So arithmetic series, guys, a series is simply the addition of the particular terms in a sequence. So for instance, let's just say I had 2, 5, 8, 11, 14. I want to ask you this question. Guys, 2, 5, 8, 11, 14. What type of sequence is this? Let's start there. What type of sequence is this? Okay, because I'm going to label it once you tell me what type it is. 2, 5, 8, 11, 14. And maybe when you tell me what type of sequence it is, give me a reason why you say that it is that particular sequence. Nolu is saying it's arithmetic. Precious is saying it's linear, classic, indeed, arithmetic sequence, no pinky, cruise. Okay. Kulegan is saying it's arithmetic as well. Nolu is explaining that it's arithmetic because it has a constant difference. What is that constant difference referred to? The constant difference is equal to what specifically? Thank you, Victoria, you are victorious indeed. Ava, thank you so much. Arithmetic constant difference. What's the constant difference? Yes, the constant difference is 3. Artie, thank you so much. So all in all, this is an arithmetic sequence. Okay. Yeah, the minute you take the very arithmetic sequence that has a constant difference of 3 and the first term of 2, when you take the very same arithmetic sequence and you do this, this now is not a sequence, meaning an ordered list of terms, but it is now called we bump it up, we call it not a sequence, but we call it come on guys, give me that word that I'm looking for. We call it thank you, a series. A series. We call this, guys, still an arithmetic. Why do we still call it arithmetic? Why is the word arithmetic still attached to this particular series that we have here? It's because this is still, in a sense, consisting of the very same terms that we had in the sequence above. The constant difference between the terms listed above is still going to be 3. The only difference is that we are adding the sequence of terms. We are adding the terms, and as a result, we call that a series. Okay, so because of the addition of the terms, we call it a series. So please, guys, okay, I mean, even you, mostly, you guys are watching, some of you, a lot of series, an addition of many episodes, and over a long period of time. And as a result, the culmination of all of those episodes is what comprises this particular series that you are watching at this present moment, whatever it is. I know some of you are series addicts, right? But please, guys, don't just understand that it is a series simply because there is an addition of the specific terms that are arithmetic. All right, that's what an arithmetic series is. Adding the terms of an arithmetic sequence. The minute you add the terms of an arithmetic sequence, you are no longer talking about an arithmetic sequence, but you are talking about an arithmetic series. The constant difference is still 3, and the first term is still 2. The only significant difference that you can do here is that you can actually add 2 plus 5, which is 7, 7 plus 8, which is something else, plus 11 plus 14, and you can get what? The first 1, 2, 3, 4, 5 terms. What is the sum? You can get the sum of the first 5 terms. S means sum. Then as a subscript, you write the number 5 to show that you are calculating the sum of the first 5 terms. Guys, please, man, in essence, that's what we are talking about. All right. Now, for an arithmetic series, there is a formula that we use for the sum of the first n terms. We use a formula for the sum of the first n terms, which is Sn for the sum of the first n terms is equal to n over 2. Then you can go ahead and say 2a plus n minus 1 d. In the situation where the last term is given of the series, then we can shorten the formula and write Sn is equal to n over 2 a plus l. What does the L stand for? L simply means the last term. And the last term generally, guys, is given by Tn, which is a plus n minus 1 in a arithmetic sequence, a plus n minus 1d. In other words, it is Tn, the nth term. All right. So if you were to actually literally substitute this part, a plus n minus 1d, then you would actually get this formula here. Okay, guys, it's fine that you are lost. You need to be lost in order to be found. So I'm going to just look at it again. What did I say to you? I am saying to you the formula for the sum of the n terms. Guys, remember, n simply means number of terms. N, S, and this n means number of terms. This is general. The sum of the first n terms. In other words, the number of terms. So that's why, for instance, if I say S5, what am I saying? I'm saying the sum of the what? How many terms are we talking about? We are talking about 1, 2, 3, 4, 5. That is the sum of the first 5 terms. So generally speaking, the n means number of terms. Number of terms. So if you want to calculate the sum of the first 3 terms, then you would say S3. In the place of n, you will have 3. If you want to calculate the sum of the first 2 terms, then you would say S2, because n means number of terms. Okay, n means number of terms. So we say whenever we want to, the formula that we use for the sum of the first n terms of an arithmetic sequence, this is the formula. Sum Sn, okay, sum of the first n terms is equal to n over 2. Then there's a bracket, 2a plus another bracket. We house n minus 1, then we multiply it by d. We close the bracket. This is the formula we use to calculate the sum of the first n terms of a what? Of an arithmetic series. Okay. So as I said, guys, if you are now specifically calculating the sum of these first 5 terms, then all you'd have to do is first find the value of a. You know a is 2. Find the value of d. You know d is the constant difference, it's 3. And then how many terms do you want to calculate? The first 5 terms. So which means in the place of n, you are going to substitute what? 5. 5 there, 5 there, and 5 there. Then you just simply substitute into your calculator and get the answer for the sum of the first 5 terms. I'm going to do the example practically so you can see what I mean. But I need to first sensitize you that the formula we use, this is also available in the formula sheet that you get when you are writing exams. The sum of the first 5 terms, for instance, you use this formula. The sum of n terms is equal to n over 2 into 2a plus n minus 1 d, close bracket. If you so happen to have the last term of a particular series, then you can use this short form of the formula. What am I saying? If you so happen to have the last term, then you can shorten. Write the formula Sn is equal to n over 2, brackets, you write a plus L. What is L? The last term in your sequence. And I'm going to practically show you using this example what I mean by that. Now someone in the comment section is saying, can't we just add the numbers that are given to us? Guys, yes, you can add the numbers that are given to you, but remember that in typical exam questions, they're never going to ask you for the sum of the first 5 terms. They're going to say to you, calculate the sum of the first 126 terms. Now, good luck finding all the terms first, all 126 of them, and then adding all 126 of them. You see how defeating or self-defeating that is. That's why you have the formula, because the formula will actually lessen the load. You will be able to just simplify right there. Sum of 126 terms, substitute 126, put it into the calculator, voila, and get the answer. Okay, so let's look at this one as an example. Let's say example 1, we are given a series 2 plus 5 plus 8 plus 11 plus 14. Okay, do you see this, guys? There it is. Yes, I'm giving you your Christmas present. Ho, 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 Merry Christmas. You guys didn't know Santa Claus is coming as a maths teacher on TikTok. There it is. You never knew, hey? Yeah, that's why some people, they actually reject gifts that are meant for them because they are looking for other things. Anyways, here it is 2 plus 5 plus 8 plus 11 plus 14 plus ... Let's just say it continues on the series. All right. Now they are saying to us, calculate the sum. The question says calculate the sum of the first 5 terms. So guys, let's just, I know we can actually add these values, but for the sake of trying to exercise this using the formula, okay, let's put it into practice. Okay, yeah. 2 plus 5 plus 8 plus 11 plus 14 plus ... Calculate the sum of the first 5 terms. Let's calculate the sum of the first 5 terms. So I'm going to do it in 2 ways. Firstly, let's write down the formula. We know that this is an arithmetic series. First and foremost, we need to establish what type of series this is. Since it's arithmetic, it means this is the formula we are going to use. Obviously, we are going to deal with geometric. We have a different formula, okay? So we want to calculate the sum of the first 5 terms. Remember, Sn means what? It means the sum of the first n terms. But we want the sum of the first 5 terms. So we know the formula. It's n over 2, 2a plus n minus 1 d. Then all we need is a. What is a, guys? What is a? A is called the... What is a, guys? A is equal to what exactly? Let's move along together so that I'll go very slow with this one so that everybody, gets to feel going through the problem together. Yes, a is 2. Remember, a is the first term in the series. So there it is. It is 2. That is the first term. So we substitute a as 2. What is d? We need d as well, right? Just for the sake of this particular problem and for the sake of this method that we are using. D is, yes, since this is arithmetic, we get d by saying t2 minus t1, we get 3, 8 minus 5, which is 3, 11 minus 8, which is also 3, so therefore d is 3. What do we want? The sum of the first what? 5 terms. That means our n is going to be 5. Because we want the sum of the first n terms. Remember, I said to you that the n here specifically talks about the number of terms. So we want the sum of the first 5 terms. Okay, now we are ready to use the formula, guys, because we have a, we have d, and we know what we want, the sum of the first 5 terms. Go to the formula, substitute in the place of n5. Then go to n, substitute 5 there. Okay, n, guys, represents the number of terms. They said the sum of the first 5 terms. So this n means the first 5 terms. That's what we want, the sum of the first 5 terms. Okay, 2a times 2 plus n is 5 minus 1 times the d, that is 3. We close the bracket. And guys, we could simply just go directly to our calculator and punch all of this in and get the answer without really bothering ourselves too much with a lot of things. Okay, I hope that makes sense. Remember, this is 5 minus 1, 4 times 3, so that's 4 plus the 12. I think we can grab the calculator if we want to. 4 plus 12 is 16. Okay, right? I mean, we don't have to go through this, what I'm doing here. Like I said, you could simply grab your calculator a long time ago and just substitute. Then 5 over 2 times 16. Okay, remember, 5 over 2 times 16, that's 8 times 5, which gives you 40. Okay, so the sum of the first 5 terms, do we all get 40? Practically speaking, guys, if you add these numbers, do we actually get 40? 2 plus 5 is 7. 7 plus 8 is 15. 15 plus 11 is 26. 26 plus 14 is 40. It is true. It is true. The formula works. So the formula is legit, right? Because practically the addition does lead to 40. Formally, it leads to 40. Let's check the other one, because we said alternatively we could use this formula as well, as long as we have the what. Come on, say it with me. As long as we have the what, we can use this beautiful Mr. Guy formula here. As long as we have the what, guys. As long as we have the what of the series, the last term. Since they want the first 5 terms, if we look at the series that we have 1, 2, 3, 4, 5. So the last term for the first 5 terms is what, guys? What is the last term for the first 5 terms? It is what? What is the last term for the first 5 terms? Because it's appropriate for the question, the sum of the first 5 terms. Yes, Nolu. The last term for the first 5 terms is 14. So let's go. Write down the formula. This one only requires A, L, and N. What is A? For our series, A is, you said it, you are saying it with me? Yes, give it to me. Thank you, Bongi. Bongi. Then we don't need D for this one. We need what? L. What did we say is the last term for the first 5 terms? The last term for the first 5 terms in this series. Thank you, Nolu. Nolu, you are back again. L is 14, and then N, we want the sum of the what, guys? Of the what? We want the sum of the first 5 terms. So our N is, thank you, Classic Presh, it's 5. Kulekani Ndlovu, thank you so much. Now we go to the formula, because all it needs is N, we have it, A, we have it, L, we have it, and then we simply go ahead and solve. 5 over 2 into 16. 16 times 5 over 2 seems very familiar. Answer 40. The sum of the first 5 terms is what? Is 40, guys. Now, please take it in this thing. All right, I'm going to go back. What did I say is a arithmetic series? It is simply still a sequence that is arithmetic, but it has plus. Okay, or there could be minus in between the terms. Okay, so it's a summation of the terms that are arithmetic. That's what a series is. Okay, then I said that for an arithmetic series we use a formula, okay, to find the sum of what? Sum of the first n terms. This n means the sum of the first n terms. The n means the number of terms that we want to add. The number of what? Of terms that we want to do what? That we want to add. All right? So the formulas are there. You have the first formula, which needs A, N, and D. N means number of terms. You have the second formula, which is used only when we know what the last term is for the number of terms that we are asked to calculate. The sum of. So since we were asked to calculate the sum of the first 5 terms, okay, since we know that it's the sum of the first 5 terms, that's why we find it quite easy then to say we can use this formula where we need A, D, and N, or we could use this formula because for the first 5 terms, the last term is there. Okay. Then you go ahead and you use this formula if you want, as long as you have the last term. Are you with me? You can use this formula as long as the last term for the number of terms that are required, you have that last term. Or you can use this one. Okay? I hope we are together now. Okay? I hope we are together. I blame. Blame game, never. Hey guys, since we are in this situation, we are in this situation, we work with the situation we are in, or we look for alternatives. Yeah. Guys, remember, maths will forever remain as a subject that is saying, if you have a problem, go and find the solution to the problem. Use the gray matter that you have and work out the problem. All right. I hope you understand what I mean. I hope you understand. So yeah, let's take it, look at another situation. Okay. Say we are given here another sequence. There it is. 5 plus 9 plus 13 plus ... plus. Then we have 401. Okay. And then the question that is first says calculate the number of terms. Calculate the what? The number of what? Of terms in the what? In the series. 5 plus 9 plus 13 plus ... plus 401. Calculate the number of terms in the series. I repeat, calculate the number of terms in the series. Kulegani is saying 401 is definitely the last term. Kulegani, you are thinking in the right direction indeed. So we have the last term for this particular series. Okay. Thank you, Science Genie. I really appreciate that. I think I am seeing you for the second time come around. Thank you, sir. Really appreciate it. I understand that you are a tutor yourself and you also have live lessons that are running, and respect to you. Back to you, buddy. Back to you. I know you are doing the most on this platform yourself. 26 is crying for your live lessons. He's asking, why did you end the live? I don't know. But yeah, let's not fail these kids. They need it. They need it indeed. 5 plus 9 plus 13 plus. So I love the fact that Kulegani indicated we have the last term. So therefore, if we have the last term, what is the last term? You will remember I said to you guys that the last term is actually Tn. Does that make sense? Last term is Tn. So that means we have to equate the last term, which is 401, with Tn. That's what it simply means. The last term is Tn. There we have the last term of the series is 401. So we equate Tn with 401. What is Tn? It's A plus N minus 1D is equal to 401. Then we can calculate what? The number. N, the number of terms in the series. So let's go ahead and calculate that number of terms. But in order to do that, we need A and we need D. So let's find A. What is A, guys? From the series, A is equal to what? You tell me what A and D is so that I can substitute those values. Let's identify them first, substitute the values, and then solve for N. Classic Presh, thank you so much. A is definitely equal to 5. You are 100% correct. Then Nolu helped us out very nicely. Nolu is seeing that T2 minus T1 together with T3 minus T2 seems to give us a constant value of 4. Because 9 minus 5, indeed guys, 9 minus 5 together with 13 minus 9 gives us 4. So very true. Thank you so much, guys. It is 4, it is 4, it is 4. So A, we can now substitute. In the place of A, we write 5 plus. Then we have N minus 1. The D is 4, which is equal to 401. I think we are ready now to distribute and solve. Algebra becomes the way out. So of course we have 5, which is a separate term. 4 times n, 4 times negative 1. Remember, this 4 is positive, okay, because there's that sign there that's positive. Okay, so 4 times n gives us 4n, and then 4 times negative 1 gives us negative 4, which is equal to 401. And this is simply a linear equation you could solve in grade 8, right? Grade 8 linear equation, guys, really and truly, there's nothing much to that because it's a linear equation from grade 8. Any grade 8 learner will be able to solve this without really breaking a sweat. Thank you so much. I really appreciate. I saw, and I'm really thankful, guys. Sorry, I feel like I'm so ungrateful. I'm sorry for not acknowledging there. I could see those you awesomes that were coming through. I really appreciate it. Gifters, thank you. I appreciate it a lot. I'm sorry, man. I feel like I'm lost in trying to explain and clarify these things that I'm not acknowledging that. But thank you so much. For N, 401, 4 minus 5. We've got negative 1. And then 401 minus 1, which is 400. Okay. Divide both sides, as you have said, by 4. We get N is equal to 100. So if this here in actual fact means the position of this term is the 100th term. Remember, guys, for Tn, the n here means the position of 401. Okay, not to be mistaken with Sn, the number of terms. This n here means the position of the last term is the 100th term. Therefore, we can then conclude that there are how many terms in this series. If this is the 100th term, it means in total here there are 100 terms in the series. Okay, because remember, guys, the question says calculate the number of terms. So this n, yes, means the position of the last term, but ultimately we'd have to conclude and say there are 100 terms in the series. Okay. Why are your methods a lot? Yes, to find the position of the if we have the last term, then of course that last term indicates, if we find the position of that term, the smart thing about using Tn when we are given the last term is that by equating Tn with that last term, that affords us the chance of figuring out what the position of that last term is. And then subsequently, we can then conclude about how many terms there actually are in our series. Okay. Guys, this is very different from what we had just done here. Remember, here we were trying to find what the sum of the series is. Whereas in this other question, we are not finding the sum of the series. We are finding how many terms actually exist in our given series. Look at the follow-up question to this one. The follow-up question is calculate the sum of the series. What do they want now? The sum of the series. The sum of which series? This one, the one we just looked at. How are we going to calculate the sum of the series? Okay. So in our heads, we are like, okay, if I want to calculate the sum of the series, then it becomes important for me to establish the number of terms in the series. Do I have the number of terms in the series so that I can calculate its sum? Okay. Because I need the sum of the series, the sum of the terms. Do I have the number of terms of this particular series so that I can be able to calculate the sum of the terms of the series? Do I have the? Yes, I do, guys. Bongi, 100%. Kulekani, thank you so much. Spot on. Nolu, no Pinky, Savage. Do I have the number of terms in the series? Because remember, the minute you use or you start writing down, can I use this formula? Is it possible then to use this formula for this particular series? Do I have all the required information that I can utilize to actually use this formula? Because remember, guys, this is forever going to be a shorter way of getting the sum of your terms. If you have the last term and you know how many terms they are in total with that last term, then you can actually use this formula. Okay. Or if you don't, then of course, Mr. Long formula is forever waiting to be used. And remember, these are formulas that get provided in your formula sheet, so they are always there. Okay. 2-6 is like, this formula is short, we want the long one. Well, you know, like I said, time becomes an essential thing when writing an exam. So sometimes when you are actually exposed to something that can actually lead you to the answer quickly and effectively without actually spending a lot of time, then you utilize that, guys. Because let me tell you this, you are going to soon learn that time is going to be your enemy when writing tests and exams. And unless you have a solid basic understanding of your concepts for all your topics, then that time issue will continue to be a problem. It's not a matter of trying to write fast, guys. You know, time is easily manageable when you have a solid understanding of the concepts for all topics. When you have that sorted and you have practiced sufficiently and you've hammered in the concepts, then the time issue just sorts itself out, because you know, whenever you come across a question, you know how to maneuver because you've been exposed too many times to the types of questions that basically come about. That's why practicing is so important. All right. And I mean, that's why an attitude like this, where people say, "Hi, it's time to rest now. We don't have to do maths." The minute you go on holiday, the maths also goes on holiday. What a destructive mindset. The maths, even though you go on holiday, the maths should never go on holiday, because the maths is going to be needed to be used. All right. So please, guys, very important. Your grade 11, those who are coming from grade 11, you're going to grade 12 next year. You think your grade 11 is not going to be essential in your grade 12 work? Yesterday, guys, you better make sure that when schools reopen, you reopen school. When you reopen school for grade 12, guys, your grade 11 knowledge and understanding needs to be on top-notch shape, as if when you are opening school, you are going to be writing your final grade 11 exams. That's how good your grade 11 knowledge needs to be. And it needs to exceed and be far better than when you wrote your grade 11 exams. Because some of you are still crying about how you did not do as well as you should have in grade 11. All right. So we can't afford to have the same, mindset cripple into grade 12. We can't have that. Grade 11 needs to be solid. Okay, 75% of grade 11 work is what you cover in 12. So please, you need that to be solid as can be. Or otherwise you'll cry. Anyways, let me stop rambling. So we know we're going to calculate the sum of the first 100 terms because there are 100 terms in this particular series. We've established that the minute we were able to get how many terms there are in our series. Merry Christmas to you too, Mary Keating and Cassidy Keating. Yeah, don't be scared, guys, to be Father Christmas as well in my life, you know. Gifts are very much welcome in the Christmas spirit, of course. Okay, then A is 5, guys. It's 5. So A is 5. Last term. Remember the last term, there it is. It's 401. Then we simply use the calculator. It should be easy to get the answer. Very simply and easy, guys. Okay. 406. Yeah, then you say 50 times 406, which is easily equal to, let's see in the comment section. Let me not steal away the thunder for some of you there. God is turning 100 years old. Oh my goodness, what in the world? Nope. Not so 26. Okay, so the answer is, come on guys, 50 times 406 gives you Abashwe. Thank you, Lint. Yo, Lint chocolate. Yo, Lint chocolate just did the things there. 20,300. Thank you so much. Very, 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 very appreciative there. Okay, and remember guys, even if you use this formula, it would still work out nicely because it would still be 100 over 2 times A, 2 times the what? The first term, which is 5, then n minus 1, the D would be obviously the 4, and then you would actually punch it into your calculator. You'd still get the sum for the first 100 terms is 20,300. Okay, yeah. So guys, I don't know if we are together here, but if we are, I hope we are, right? And I know some of you now want for geometric series. Okay, let's look at the sum series for geometric. Okay, let's say for a GS, okay, geometric series, we have 1, 2, 4, and 8. What type of sequence is this? Okay, just to change channels here. 1, 2, 4, 8. What type of sequence do we have there, guys? We have a, thank you, Nolu. We have a geometric, but please guys, be specific. It's a geometric sequence. Why sequence? Because it's a list of ordered terms and they have a constant ratio of who? You can see the constant ratio most from 1 to 2, from 2 to 4, from 4 to 8. You can see the constant ratio. The minute we change that up and we do this 1 plus 2 plus 4 plus 8, what is this now? What is this now? We call this a what, guys? Yes, 2, 6. Thank you so much. Kuligani, thank you so much. Yes, it's multiplied by 2. The constant ratio is 2. What type of what do we call this? 1, 2, 1 plus 2 plus 4 plus 8. We call it a, thank you, Nopindi. It's a geometric series. Yes. So, with this geometric series that we are then talking about, Nolu, how do we find the constant ratio? Constant ratio, we find it by dividing term 2 divided by term 1. 2 divided by 1, that gives us. Then you can check again with term 3 divided by term 2 just to verify that it actually works. Term 3 divided by term 2, 4 divided by 2 also gives us what? Again, 8 divided by 4 also gives us what? So we are getting a constant ratio of what? of 2. That's how we calculate the constant ratio, my dear Nolu. Are you with me now, Nolu? Nolu. Oh, Nolu. Nolu. Okay, thank you, Nolu. Nolu, I hope you are clear now, guys. So when it's a geometric, that's how we calculate constant ratio. But remember, when it is arithmetic, then we subtract. We say T2 minus T1, T3 minus T2. We confirm it in that way. So let's always verify and confirm. They will explicitly tell us sometimes that this is a geometric series. So we will know, okay, constant ratio and first term. Constant ratio, T2 divided by T1, confirmed by T3 divided by T2. With an arithmetic series, constant difference, T2 minus T1, we confirm with T3 minus T2. Okay, you see, this is exactly what I'm actually, which is just, you see, now I'm busy with this. Look at 2,6 there. Say, when will you do sigma notation? When will you do sigma notation is giving us challenges, right? Remember, my dear friend 2,6, we'll get there. Currently, there were people that were crying about geometric series. I'm still trying to get through that. So let's just be patient a little bit. I'll get there eventually. Okay, I'm getting to sigma. Don't worry, sigma is coming up. I'm going to deal with sigma before. Yeah, you see, it's after 12 now. But I'm telling you, my friend, I'll go to sleep. Sigma will have been sigma'd. I will sigma. Okay, so geometric series, there it is. 1 plus 2 plus 4 plus 8. Now, please listen. The formula that we use, I repeat, the formula for the sum of the first n terms of a geometric series is, what is it, guys? Sn is equal to, there's 2, a into brackets r to the power n minus 1 over r minus 1. Or there's this one. Sum of the first n terms is equal to a into 1 minus r to the power n over 1 minus r. These are the two formulas. Formula 1 is always convenient if your r value is actually a value that is greater than 1. In other words, if your constant ratio is greater than 1, then this formula is very much conducive for that. If your r value, formula 2, is less than 1, then this one is convenient or conducive for that situation. So you must monitor and take note of the situation of r. You know how to calculate the constant ratio. You take T2 divided by T1 and then you find what r is. Here in this case, r is equal to 2. That means r is greater than 1. So this would be the formula we would use to calculate the sum of the first n terms. But in a situation where r is less than 1, then you would use this formula to calculate the sum of the first n terms. Okay. So let's be practical. Let's look at an example. Maybe just for a moment, let me just show you what I've just done here holistically. So as I was saying to you guys, that the formula for the sum of the first n terms of a geometric series is calculated either by using the first formula, sum of the first n terms is equal to a into r to the power n minus 1 over r minus 1. We use that when r is greater than 1. Or we can use the sum of the first n terms is equal to a into 1 minus r to the power n over 1 minus r. we use this formula when r is less than 1. Please take note of what's inside the bracket. When r is less than 1, 1 minus r, 1 minus r. There in the bracket, there's a power n to the r. Here in the denominator, there's no exponent n. Look at here. In the bracket, it's r to the power n minus 1, it's r minus 1. Once again, the r has an exponent n. Okay, these are formula that it's good when you know these formulas off by heart, but of course you will have the formulas available on the formula sheet. They should provide the formula sheet for you to be able to utilize the formulas when the need arises, when you want to calculate the sum of the first n terms. Are we together? When you want to calculate the sum of the first n terms, they should be able to provide those formulas for you to be utilized. Together, forever and ever, forever, ever, and ever, ever. Are we together? Forever, ever? Okay, seems like you guys are ready for some action. Okay, determine the sum of the first 16 terms of the geometric series. Determine the sum of the first 16 terms of the geometric series. Determine the sum of the first 16 terms of the geometric series. Determine the what? The sum of the what? Of the first what? 16 what? Terms of the what? Of the geometric series. We want to determine the sum of the first 16 terms. Okay, and the first 16 terms, these are the terms, guys. Look at this. 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 These are the terms. The sum of the first 16 terms of the geometric series. So this is what I was saying to you guys earlier on, that sometimes your series will be made up of the addition and subtraction of a particular sequence. So let's practically think about this. This, in other words, is 1, that's negative 2, that's positive 4, that's negative 8, that's positive 16. Does that make sense? But the minute you write this as a series, you don't write the commas that separate or the semicolons that separate the terms. Rather, you are basically just adding the terms as they appear. 1 minus 2 plus 4 minus 8 plus 16. This is a series because there's a plus and minus sign between the terms of the sequence. Are we together, guys? Okay, so I want you to be shocked, but to not be shocked again. Okay, I want you to be shocked, then come back to Mother Earth and be like, oh, okay, so basically in all, sir is saying here, we can actually calculate the sum of numbers that are positive and negative. Okay, but is this geometric? That's the $1 million question that you would want to ask, right? Because at the end of the day, we want to calculate the sum of this series. So let's unpack, because we know the formulas that we have, but first, before we choose an appropriate formula, let's find A and then let's find R. So our A value, you tell me, guys, in the comment section, what will be my A value? A is equal to what? So that I can find A and find R. Lonjengo Bese, thank you so much. So A is equal to 1. No pinky as well. Very first up in the dial. Remember, guys, 1 is positive. Be very careful. 1 is not negative, 1 is positive. Remember, the sign of any term is on the left hand side. The sum of this term is on the left hand side. The sign, of the term is on the left. Don't confuse it. So A is 1. What about R? What is R? Remember, when we calculate R, we say T2 divided by T1. We can also confirm it by T3 divided by T2. It should yield the same value. So in other words, -2 divided by 1 should give me the same answer as 4 divided by -2, which both give me what? -2. So R is -2. Okay. Now, we need to establish something very quickly here. Our A value is 1. Our R value is -2. What can we say about R? R is actually less than 1. R is less than 1. Why is that important for us to know? What does that assist us with, remember? Yes, Nolu, thank you so much. Which means when we know what the condition of R is, that helps us with the choice of the formula that we use. So we're going to use the second formula, as you've said, Nolu. Thank you very much. So we go ahead and we write down that formula so that we know what it is. Sum of n terms is A into 1 minus R to the power n. Hey, what in the world is happening now? We're having people who want to marry here. Modimo. Ribo Kawena. My goodness. It's all Raigane. What in the world, Dimni? What is this? Please, guys, I don't want people proposing on my live. Please, please, please. This is not the place. 1 minus R. Okay. Now, what do we want? The sum of the first 16 terms. So our n value is going to be 16. Okay. Yes, the champ mesh. You can ask a question. What question would you like to ask? Go ahead. Shoot. What's your question? The champ mesh. The champ mesh. Can I ask a question? Yes, you are here to ask questions and clarify anything that you might want to clarify. It's 20 past 12. It's already Christmas. Merry Christmas to everyone. Yeah, hopefully this is a merry and indeed Merry Christmas. You guys are crossing live with me. Busy with maths. Are you kidding me? 20 past 12. You guys have no life. That's for sure. Okay. Because you want to make a better life, that's fine. Okay, A, what am I doing here? Yeah, you probably were drawn in by the FYP page, but if you don't know what you are doing here, you can always extend your Christmassy spirit and gift us very handsomely on the live. Support the live creator and gift us Shin B, and then you can be on your way. You will have played Santa role after midnight. Some of the first 16 terms, our lives are in our hands. Very good, very true note. You're tired of maths? Okay, well, you can be tired. Gift me and you can leave, my friend. No problem. Just send me a nice galaxy so that I can go see Santa and then you can actually leave the live. No problem. I'm sure it will be your first gift as well because I can see you have no gifting history, it seems. How did I get R? Rewind. Remember, term 2 divided by term 1. That's how we calculate the value of R. -2 divided by 1. We can also further confirm it with term 3 divided by term 2. 4 divided by -2. That gives us -2. That is how we get R. Don't we use this method when R is less than 1? Okay, currently, how is R, my good dear friend Champ Mesh? Don't we use this method when R is less than 1 but greater than -1? No, this method we use it when R is less than 1. It's convenient. That's the word that they use. It has a convenience using this particular formula. whenever r is less than 1, we use this formula. Okay, so hopefully that clarifies that, the champ mesh. I appreciate your question, but that's exactly what we ought to know. We use this formula when r is less than 1. So r is -2. This is a value that is less than 1. So we use this formula. So let's go ahead and use it. A is 1 into 1 minus, then r, we get -2 to the power what? 16. Okay. 1 minus -2. Okay. 1 minus 2 to the power 16. So we can just, after substituting, guys, it's easier to just simply use the calculator, just there and there on the spot. We don't have to necessarily simplify all of that and simplify everything, because our priority there is to get that answer that we need, which basically will help us in our answer. So there we have 1 minus 2 to the power 16 for the numerator. That is what we get. Then we divide that. Remember, 1 minus -2 will give you 3. You divide that by 3, that is positive. You get -21,845. So the answer for the first 16 terms, the sum of the first 16 terms, will give you -21,845. -21,845. That's first 16, right? The sum of the first 16 terms. Does that even make sense? Does it make sense, guys? Are we sensing some sensibility in the answer? Schools are closed, but our minds are open. It's your girl. This is the key thing. The schools are closed, but our minds are open. They are not closed, guys. This is the significant thing about knowledge and education. Knowledge and education is not dependent on open schools. Knowledge and education is very much independent from that. Okay, that's why some of you and most of you, what do you guys do when you praise the people that have helped you? You tend to praise all these amazing, what you might call content creators like Kevin Maths and Science. I will give that guy his his flowers, because you guys, without fail, will declare such in your TikTok videos, and your thanking whatever. Previous matriculants have also uttered many things. So please, even though schools are closed, the mind is open. The internet is ablaze with content. There's many content creators that have knowledge available for us to sponge off and absorb, so that we are equipped by the time schools open. The event of schools opening will simply be a ceremonial thing to say welcome back, but our minds will have been opened long time ago, and we will have absorbed knowledge sufficient that when we go back to that place, we are simply just going to get what we deserve, what is due to us, and get the marks that we deserve, so that we can open more doors for our own personal lives and access more opportunities that are due to us. That's all. So let's stop this notion of wanting to close knowledge and learning simply because the institution is not opened. It's nonsense, that thing. And this is the thing that is holding and keeping us back. Okay, it's nonsense, rubbish. I want to declare it now. It's Christmas, and Christmas is a time to learn. Christmas is a time to learn. Jesus came so that we can denounce ignorance and reclaim knowledge and wisdom. S to the power 16 is equal to that. We found the sum of the first 16 terms for our geometric series. So guys, this thing is not a problem. Okay, this thing is not a problem. Okay, I hope you are okay now. I hope all is well. Let us move now and leave this world. I think we have an idea now of sigma, of the geometric series and the arithmetic series. The rest is to be done by you, right? You now need to just go and apply yourself and do the rest. The rest is in your court to do. The last thing I want to do now is to address this idea of sigma, because 2-6 was crying earlier on and saying sigma is disturbing him. It's not giving him a nice time. All right. So remember, guys, that we've just looked at one scenario, calculating the sum of the first 16 terms where r is less than 1. There are many situations where maybe r is greater than 1 and it might need us to use the first formula. All right. And there's other scenarios that basically I haven't looked at, but the concept at least of geometric series and the formula and the concept of arithmetic series and the formula has at least been covered, right? The rest is up to you. All right, and maybe the rest I'll also look at in future live sessions. Are we together? Oh, okay, I see you there in the comment section. Khulekani Ndlovu is like the constant ratio. Okay, and what you are specifically talking about is what we call a converging geometric series. What is it? A converging. Thank you, Lwandla, for the finger heart. A converging geometric series. Okay. A converging geometric series. The word converge. Okay. It's like we are approaching something, we are heading in a particular direction. Okay, converging. Okay, converging. I will look at converging just shortly. Just allow me to take the route that I currently want to take, and then I will get there to converging. Okanye, you want me to take care of converging before I get there? Okay, want me to get straight to converging? Okay, let's just first look at sigma notation. We'll come back to converging geometric series. I'll explain what that means. All right, but thank you for bringing that up, Mr. Khulekani Ndlovu. We'll look at converging just shortly. Let's just look at sigma. Guys, this guy here, surely you've seen this symbol before. This is a Greek symbol. It's a letter of the alphabet. The Greeks have many letters, all right? I'm sure you've seen some of them like theta, beta, there's many, man. Theta, beta, phi, there's many, So now we have this one as well, we call it sigma, all right? Sigma notation. This here, sigma, means sum, right? It is used to refer to the sum of something, okay? Sum means addition, okay? That's what sigma, sum, addition, okay? So if I said, for instance, the sigma of P, let's say, for instance, that means the sum of P's. Okay? In other words, P plus P plus P plus P plus P. Okay? That's just loosely put. All right? If I say the sigma of P, because I said to you guys, the word sigma means sum. So if I say the sigma of P just means the sum of P's. We are adding P's, P plus P plus P plus P, and so it goes, if that makes sense. Now, let me now be more specific to what we are dealing with. Right? Be more specific to what we are dealing with. This is sigma. Typically, with your sigma notation, when it comes to our series, there is a number at the bottom of the sigma symbol. There is a number at the top, okay? And then there is a formula, okay, that basically is placed next to the sigma symbol, right? So the number at the bottom, let's just say we had, for an example, P is equal to 1. Then at the top, we had 5. Then next to the sigma symbol, we have 2P. I want us to understand what the number at the bottom actually means. So the number at the bottom simply refers to the first number that we are going to substitute where into the formula. We're going to substitute into the formula. Which formula? This one, which is 2P. We are going to substitute into the general term. So I will call that the general term, or the nth term if you want to call it. So we have 2P here. It is basically linear in nature, right? Because it's 2 and next to 2 there's a P. So the first number we are going to substitute, since P is equal to 1, it means we are going to substitute P as 1. Then there's a number at the top. This number at the top is actually referred to as the last number that we are going to substitute for our series. So let me be practical here. This then means that P is equal to 1. We start by substituting 1 in the place of P. So that means our first term in the series is going to be 2 times 1 plus, because this is a series, it's a sum. The next number we are going to substitute after 1 is going to be 2 plus the next number we substitute is going to be 3 plus the next number we substitute in the place of P is going to be 4 plus the very last number we substitute, because we are going to do what, guys? The last number you substitute. We said that the top number is the last number that we substitute, whereas the number at the bottom is the first number we are going to substitute into the formula. So the last number we substitute is 5. Does that make sense, guys? So all in all, if we are looking at the terms of this particular series from the general term, we have 2 plus 4 plus 6 plus 8 plus 10. These are the terms of the series for this particular given sigma. Okay. Yes, Nolu. If P, okay, I'm going to look at an example of that nature, for instance. I'm going to give you another example. Let's look at a different sigma. Let's say we had x is equal to 4. Then at the top, we had 8. Then here we have x squared. Okay, makes sense? So for this particular one, what does this mean? Remember, the bottom number means the number that we substitute to start. So let's go ahead and do that. 4 to the power 2 plus 5 to the power 2 plus 6 to the power 2 plus 7 to the power 2 plus the last top is the last, so we substitute 8 to the power 2. What does that then result in? 16 plus 25 plus 36 plus 49 plus 64. Okay, that would be our series for this particular sigma. Okay, let's look at the last one so that you guys get the concept very much hammered in, because that's what I'm doing most. Hammering in Mr. Concept. (3p minus 2). Once again, linear in nature, all right? The general term is, but then this is where we start. This is where we substitute last. Okay, so top is last, bottom is first. Last, first, last, first, last, first, last, first. Okay, so if we were to then substitute here, like in exams, guys are funny. Okay, x was already involved. Let's put k here then instead of p, seeing as though you want to have k involved like in exams. All right, remember guys, I'm just covering the concept here. All right, the time will come when I'll just do exam type questions, because at the moment I'm trying to at least have the concept in our heads. Substitute 1 plus substitute 2 plus substitute 3, and then lastly substitute 4. Okay, because that's the last that we substitute. And remember, that's 3 minus 2 plus 6 minus 2 plus 9 minus 2 plus 12 minus 2, which gives us 1 plus 4 plus 7 plus 10. This here is the series that we get from our sigma. Okay. And of course, guys, I mean, remember, what's the whole objective of this thing? We need the sum of these terms, all of them. So 1 plus 4 plus 7 plus 10, you could ultimately add all 1, 2, 3, 4 terms. And what is the answer? What's 1 plus 4? 5. 5 plus 7? 12. 12 plus 10? 22. Okay. Same thing here. What's the objective at the end? To get the sum. 16 plus 25 plus 36 plus 49 plus 64. You get the sum of the terms. Makes sense, guys? All in all, we are getting the sum of the terms. Okay. Yeah. And remember, guys, we are focusing on the letter. If here we have x, it means we substitute 4 in the place of x. If we have k, that means we substitute. If here there's k is equal to 1, we substitute k is equal to 1 to begin with first and then 4 last. This is so important. Okay, so we deal with substituting in the letter that is there. Okay, mathematics on Christmas. Ngeke. Yeah, that mindset is the one that will block you from many things. Ngeke. You know, yeah, if you're going to the science class next year, any advice, you better make sure that you are starting early. Okay, so you make sure you join my live sessions when I'm doing grade 10 maths, and you start early. You go to my YouTube channel, you go to the playlist there for grade 10. You go to my YouTube channel, the link is in my bio. You go and click on the playlist for grade 10 maths, and you start absorbing every last bit of those live lessons that I did for the grade 10s for term 1. Those lessons I did last year, 2024, in December. And the kids that basically watched those lessons, they were able to score high marks. Tlohidi was here earlier on, when I was doing the grade 11 lesson, and he was basically testifying that 90% term 1 was his for mathematics because of those early prep classes. So please, guys, get cracking, man. Don't wait for anyone. It's your future. You want what you want, so get started early. Yeah, get ahead of the game. Fortune tends to favor the most prepared. Make people turn their heads next year about you and how well you are doing and your performance. Don't leave it to chance. The time to leaving things to chance has passed. Yeah, okay. So yes. We add. Key December, boss. I love it when people say Key December indeed. All right. Nobody knows that better than I do. Key December indeed. Okay, so we're getting the drill there. Getting the drill there, getting the drill. Okay, let's just look at one more. Okay, k is equal to 1. We have 10 there. Now look at this one. Okay, look at this one. K is equal to 1. You have 3 into 2 to the power 1 plus k. The minute you see this, then it means that the exponent, the variable is your exponent. Then automatically, if you have exponential variables, that means this is a geometric series. Okay, exponential variables speak GS, whereas linear expressions speak arithmetic series. Does that make sense? And guys, you can see it. 1 plus 4 plus 7. There's a constant difference here. You can see this. This is really speaking arithmetic. And look at this one. 2p. This is also speaking arithmetic. Look at it. 2, 4, 6, 8, 10. We have a constant difference of 2. You see? I hope you understand what I mean here. Because remember, the sum of the terms that they usually want you to find sometimes is not, within the scope of something that's finite. It might be more than what is ordinary. And adding all of those terms may not be sufficient. So you may need, in certain instances, to actually use the sum formulas that I have introduced to you. All right. So in this situation, for instance, this is from 1 to 10. I'm not going to waste my time and write all of the terms and add them. No. Look at this, guys. I'm going to show you. So if we are going to start here, let's start. It's fine. And to start, let's at least get the first 3 terms. You know what I mean? I hope you know what I mean. Let's at least get the what? The first 3 terms. So let me just show you here. We have 3 into 2 to the power 2 plus 3 into 2 to the power 3 plus 3 into 2 to the power 4. What does that mean? 2 squared times 4, that's 12. 2 to the power 3, that's 8 times 3, that's 24. 2 to the power 4, that's 16 times 3, that's 48. Okay, now I know that there are other terms, right? And I can go ahead and punch in that very last term, substitute 10 there, so that at least I know what that very last term, I know there's many other terms, but that very last term, we substitute 10 there, that means 2 to the power 11. So we have ... plus 3 times 2 to the power 10 plus 1, which is 11. Yeah, very big number. 2 to the power 11 times 3, you can get what that number is. All in all, what I'm saying is, this is something now that I want you to take into consideration. When you have a lot of numbers, don't waste your time and write all of the numbers and get the sum. Rather, this is something you need to note. 1, of course, at least the first 3 terms. Step number 1. 2. Step number 2. We need to figure out the number of terms we actually have in the series. And to get that, we take that top number, we subtract the bottom number, and then we add 1. This is a rule we can use whenever we want to figure out the number of terms in a given series. I repeat, take the top number, that is 10, subtract the bottom number, that is 1, then you add 1 to it. So what is 10 minus 1? That is 9. What's 9 plus 1? That is 10. So n is equal to 10. The number of terms, please, that is the next thing you need to establish. What is the number of terms in the series? How you go about that is you take the top number, subtract the bottom number, then you just, as per norm, add 1. Guys, always add 1 so that you can then clarify how many terms there are. So there are 10 terms in total. 10 of them, that's the number of terms that you have. 3. You must then find A and R, of course, if it's a geometric sequence. But if it was a arithmetic sequence, you would find A and D if it was a arithmetic sequence. So here we are having a priority of finding A and R. Why? Because it is a geometric series that we have there. Make sense? So our A value here, what's A, guys, in this series? 12, 24, and 48. What is A? And what is my R? Let's first get A out of the way. And then what is R? Bongi, thank you so much. Bongi, A is 12. Bongi, it seems like sleeping is something that's very far from your eyes, you know, and no Pinky. The funny thing is both of your names end with I, at least the shortened versions of your names. No Pinky and Bongi. And you guys are the first to answer the correct answer. So A is 12 indeed. Okay. Then R is the constant ratio. So constant ratio, guys, we know that when we want to find the constant ratio, we say T2 divided by T1. We further confirm it with T3 divided by T2. So 24 divided by 12, guys, you guys are 100%. Lizwe, Nopinki, Lwandle, Phahla, the gang, it's 2. T2 divided by T1, T3 divided by T2, it's R. That is 2. Now, we can see that our R is greater than 1, which is beautiful because for the sum of the first 10 terms, it means that we are going to use which formula? We are going to use that first formula. So let's write it down. Let us write it down. There it is. That is the formula we use to calculate the sum of the first n terms when R, the constant ratio, is greater than 1. Do you remember that, guys? I hope it's coming back. Okay. Then we can go ahead. What are we calculating? The sum of the first n terms. Thank you to this amazing usage of top minus bottom plus 1. We're able to find the number of terms that we need to calculate for the sum of those terms. S10. A is 12. R is 2. 2 to the power what? 10. Minus who? 1. Over 2 minus 1. Then we grab the calculator. We punch these things in and we get the sum of the first 10 terms using the formula. And that's that. That is that. Okay. Alpha X Music, you don't even need to be knowing this because this is grade 12. You are in grade 9. So I'm sorry, I'm not going to address any particular concerns you may have specifically with this because grade 9 content is not going to be exposing you to this. Yes, Ava, it will be on YouTube. I will upload it the minute I'm done with the live. Hopefully it actually helps me out in downloading quick. Okay, then you can grab your calculator. You guys tell me what you get as your answer. 12. In the place of A, we wrote 12. In the place of R, we wrote 2. The exponent 10, there it is. Minus 1, there it is. Close the bracket. Over 2 minus 1. This is the formula that we use. Remember, guys, whenever we want to calculate the sum of a geometric series. Nopinki is saying the answer is 12,276. And my people in the comment section will confirm if whether that answer is correct or it is bonkers. 12,276. Nopinki is like I said, is like doing the things there. Thank you, Lwandle, confirming correct indeed. It is 12,276. Okay, then that is beautifully and well done. So what am I saying to you guys? What I am saying to you guys is that whenever the situation warrants you that you don't go through writing all the terms in that particular series, simply write down the first 3 terms of that particular series. First 3 terms. Okay? And you do it by substituting top, okay? And then the consecutive numbers after the first term the first value that you substitute. You substitute 2, you substitute 3, and then you get the first 3 terms. From there, please establish how many terms there are in the series. How? By taking top number minus the bottom number and adding 1. There are 10 terms in the series. 3. Find A and R. Where? From the series. You have A as your first term. you have r. Remember, r you calculate by taking the second term in a geometric series divided by the first term. Then confirm it with term 3 divided by term 2. Once you get to find out what the value of r is, you then go ahead and you write down the sum of n of the first n terms for a geometric series where r is greater than 1. Write down the formula, you substitute, you use your calculator, you get the sum of the first 10 terms. Ain't no way, it's Christmas, blood. You can just go ahead and give me a Christmas gift. Thank you so much, Lee, rather than comment in the comment section, because you are basically trying to stop a moving train. Get out of the way because you are going to be run down. Get out of the way. I'm warning you. Okay. So guys, hey, I hope we are feeling this. We are feeling this. No, give us the gift by vanishing. That's also fine. Yeah, I think I've established, Now remember, guys, this series can be geometric, as you've seen here, but sometimes it can be arithmetic. And you can do the same thing. Find the first 3 terms. Find out the number of terms by taking top minus bottom and adding 1, getting how many terms there are. Finding A and D if it is a arithmetic series, or finding A and R if it's a geometric series. Then substituting in the appropriate formula. Remember, for arithmetic series, you have those 2 formulas that you can use. If the last term is there, you can use the formula with Sn is equal to n over 2a plus l in brackets, or you can use the other one. Okay, and please, guys, calculator, and that's that. I don't know if you guys want me to actually, show you this page a little bit longer, and then I'm going to now conclude. Okay, in the next 30 minutes, I'm just going to explain converging geometric series and sum to infinity, and that will be that for today. And then everything else, it will be actually something we will take care of at another time. So you make sure you have followed the Live Creator, you click those things that will notify you when I'm live, so that when I'm live you can be able to pick up where we left off. Or you can always go and watch the raw YouTube video that I upload as it is, because unfortunately, guys, I upload these live lessons as they are. No editing, no soft peddling. So all the comments and all the things that I said, they are there. All right. So I am just going to, I hope it's clear, this one. Converging geometric series, and that's that. Okay, Bongi, I don't have a clear. I think I'm not going to go live today in the evening, because it seems like really people need to have a bit of Christmas. Maybe Boxing Day 26. We'll see you then. Just give you a breather from me, a little bit. Also give you a chance to really digest everything that has happened so far. All right, so I'm now going to turn a bit of attention to geometric series. What is geometric series? Converging. Specifically, what a converging geometric series actually is. A convergent geometric series, sometimes referred to a converging or convergent geometric series. When a series converges, what do we mean by that? So let's just consider a particular sequence here. 1 over 2, 1 over 4, 1 over 8. This is a sequence, obviously. Why do we say it's a sequence? It's because these are a list of terms. There's no plus or minus sign that is between the terms. Okay, does that make sense? So this is a sequence. Can you guys tell me what the ratio, the constant ratio of this sequence is? Okay, I need someone to figure it out and then let me know in the comment section so I can write down what the constant ratio is. I'm just going to write R is equal to, I'm going to wait for you guys to tell me what that is. Umfupi, imfupi. Okay, you guys are saying it's half, not 0.5. Thank you very much. Now guys, very interesting. So that means if I was to continue with this sequence, something interesting is happening as we continue with this sequence. Okay. And I love the fact that you guys said it yourselves that, let's see, if this is 1 over 2, 1 over 4, that means if we multiply by half, we continue, we have 1 over 16, 1 over 32, 1 over 64, 1 over 128. We can go on and on and on. But something interesting is happening. 1 divided by 2, you press SD, this is not 0.5. 1 over 4, 1 divided by 4, you press SD, it's not 0.25. Merry Christmas to you too, thank you so much. 1 over 8, 1 divided by 8, something very interesting. Look at this, not 0.125. 1 divided by 16, not 0.0625. 1 divided by 32. Okay, I'm just kind of like showcasing here what we are having, what situation we are basically having here. 1 divided by 64. Okay, basically what you should be able to see here is that as the sequence continues, the values are getting smaller and smaller and smaller and smaller and smaller. Okay, and as they get smaller, and if you continued, you will find that these values, they are approaching this guy, all right, 0. Now guys, when you approach 0, okay, it means that we don't actually get there, but we get closer and closer and closer. Okay, we get closer and closer and closer. All right, so that means this sequence converges, it converges, approaches, the terms approach 0. That's why we call it a convergent sequence. All right, we call it a convergent sequence because it is approaching a specific number. Now, if we will consider the same terms, but this time round, we consider them as terms that we are going to actually represent in a series. All right. Okay. If we consider the same terms in a series this time round, however many terms we seem to add together, those terms will always be less than 1. Let me show you what I mean. If you took the first two terms, 1 over 2 plus 1 over 4, just from your calculator very quickly, 1 over 2, you add 1 over 4. That is 3 over 4. Now 3 over 4, guys, is 0.75. The addition of these two numbers gives you 0.75. Let's say we extended it, okay, and we decided to add 1 over 2 plus 1 over 4 plus 1 over 8, just up until these 3. Let's say we didn't add the first 2, but we added the first 3. Now you would think maybe, we're going to have a situation where we can finally get over 1, right? But what do you notice? When we add the first 3 terms, we actually get 0.875. Now, that's fine. Let's extend it further. Let's add the first 4 terms, meaning we are now just going to make sure we are adding 1 over 16 to everything that we have. Let's see, hopefully we'll get 1. Okay, 0.39375. You add these, you get 0.37. Okay, no, it's fine. Let's add. Surely if we add 1 over 32, that should sort things out. We should eventually get over 1. Hopefully, surely. Habe, 0.696875. Okay, we're getting very close. 0.96875. No problem. Let's add, up until 1 over 64. We should get over. Finally, this time around, we are getting over that 1. We're getting over. 0.984375. Now, guys, the sad truth, we can continue adding the next and the next and the next number. You would think we'll eventually get to 1. But let me tell you this. However many terms are added for this particular series, however many terms you decide to add, the sum will always is going to be less than 1. Currently, 0.984375 is less than 1. It just means the addition that we have is not going to have a significant impact around here. It's just going to have an impact down there, but it's not going to change anything when it comes to what? Making sure that our value is 1 or greater than 1. So what are we saying here? All in all, what we are saying is that it is clear that when a series is like this, however many terms we add, when the sum is seemingly less than 1, okay, there is a particular formula for finding the sum of a convergent series. There is a particular formula for finding the sum of a convergent geometric series. So yeah, we can say that the sum here approaches 1, but it does not exceed 1. So for us to get the sum of a convergent geometric series, we actually utilize a specific formula, okay? And we call that formula the sum of an infinite series. Sum of an infinite series. It is given by the formula A over 1 minus R. This is the formula. We utilize it when our constant ratio is typically between -1 and 1. Okay, then we use this formula. All right, so this is very important. Okay, a convergent geometric series. All right. So as I said, the sequence here of this particular geometric sequence, first and foremost, we had established that the terms just get smaller and smaller and they are approaching zero. That is the sequence. The series, when we add the terms of the series, they actually will be less than 1, will never get to 1, will never be greater than 1. So that's a convergent geometric series. And therefore, a convergent geometric series, we use this formula to calculate the sum of a what? Of a convergent geometric series. We use the sum to infinity, which is equal to A. A means the first term, R means the constant ratio. So guys, as you had said earlier on, if I'm going to be calculating the sum of these terms, all right, the sum of these terms, so I'm going to use S infinity is equal to, the A there means the first term. First term, of course, is half, as you have seen there, that is half, that's the first term, over 1 minus, now, constant ratio, you guys established that the constant ratio is half. So we have 1 minus half. Then we grab our calculator, we use that. The sum to infinity is equal to 1. So the sum of an infinite series is given by this formula, and when we utilize the formula, we actually find that it approaches 1. Okay, it approaches 1. So we say the sum to infinity is equal to 1. All right, yeah. Let us look at a concluding example for the sum to infinity. So we have 3 plus 1 plus 1 over 3 plus 1 over 9 plus 1 over 27 plus ... Now, the question is saying use, specifically, the question is saying use the formula S to infinity is equal to A over 1 minus R, where R is between -1 and 1, to find this sum to infinity. Okay, Merry Christmas to you too, Auntie Waffles. We got Auntie Waffles. Okay, I'm guessing Uncle is sick and tired of, yeah, so have Auntie. Thank you so much, Landle, for the gifts. I really appreciate it. Merry Christmas to you all, to y'all. Okay, so let us close this thing up. So given the formula, we want to use sum infinity. So what do we do? First and foremost, we calculate. We find A. A is equal to 3. We find R, 1 divided by 3. 1 over 3 divided by 1. So R is 1 over 3. There it is. That's R. Then R, you can see, guys, is between -1 and 1. That 1 over 3 is typically a value between -1 and 1. So we can go ahead and say sum to infinity is equal to A, that's 3 over 1 minus 1 over 3. You can grab your calculator, guys, and you can punch this in, of course. So that will be 2 over 3. 3 divided by 2 over 3 will give us 3 times 3 over 2, which we know is 9 over 2. Is that correct? Or am I correct? Yes. 9 over 2. Yes, Colorado. Yes. So sum to infinity is 9 over 2. All right. That would be our sweet, beautiful answer. All right. I hope that's very, very, very clear for all of us. Now I want to say that yeah, so for a series to converge, guys, the value of r must be between -1 and 1. Okay, I think that's very important to note. For a series to converge, the value of r must be between -1 and 1. Okay, so I'm just gonna conclude with these questions, and let's look at calculate. This one is saying calculate. Okay, I'm going to end the live at 1:30, guys. All right, yeah, I hope you guys can bear with me. Calculate sum to infinity if it is possible. Okay, so hopefully you guys can see if whether it's possible or not to calculate sum to infinity. Here is a series: 6 plus 3 plus 2 plus 3 over 2 plus ... Okay, can we calculate sum to infinity here? Okay, remember, a series converges if the value of r is between -1 and 1. So 6 plus 3 plus 3 over 2 plus ... Is it possible here to calculate the sum to infinity? That's my question to us, because this one is saying calculate sum to infinity if it is possible. Okay, so my question is it possible to calculate sum to infinity? Elite is saying yes, Alpha is saying yes. Okay, is it possible? Yes. Remember, guys, if r is between -1 and 1, then it is possible to calculate sum to infinity. So they are saying calculate sum to infinity if it is possible. So let us just see here for a moment there. What are we saying then? We are saying r, what is r? 3 divided by 6. What's 3 divided by 6? It's half. 3 over 2 divided by 3, that also gives us half. So half is definitely a number that's between what? -1 and 1. It's in between. So that's fine. We can calculate sum to infinity. Does that make sense? A is 6. So we say sum to infinity is equal to 6 over 1 minus half. 6 over 2 minus 1. 1 minus half is half. That's 6 times 2, which is 12. So sum to infinity is 12. Make sense, guys? Yeah, because of this condition, the value of r is between -1 and 1, and half is a value that's between -1 and 1. Okay, very important. Let's look at the next question. Calculate it. Still same thing, sum to infinity if it is possible. 1 minus half plus 1 over 4 minus ... Can we calculate sum to infinity here? 1 minus half plus 1 over 4 minus ... Is it possible to calculate sum to infinity? If it is, please go ahead and calculate sum to infinity. If it's not, then say so. No, so we can't calculate sum to infinity here. Alpha X Music is saying yes. Repeating it again, almost as if Alpha X is spamming my live. Ka December mara guys, Rene. Kitla ubona ka January Rene. Cash content. I can just see Rene is driving to cash content. Yes, guys, we can calculate sum to infinity. So what is it then? A is equal to 1. R is equal to what? T2 divided by T1. That's -half over 1. That's -half, right? Yeah. If we divide the T2 divided by T1, T3 divided by T2, okay, we get -half. Okay, then of course, sum to infinity, we see -half, that's between -1 and 1, so that works out nicely. So sum to infinity is 1 over 1 minus a half. Then we go ahead, we say 1 over half. And then final answer, it's 1 divided by a half. One divided by half is the same thing as 1 times 2 over 1, which is basically the answer is okay. Are we falling or flowing in the same kind of direction, or did I miss the boat somewhere? No, sir, it's negative half. Is it true? Are you sure? Okay. Remember, this one is 1 minus r. Okay, did you see the error that I made? Hopefully you guys can see the error that I made there. Remember, half, the r is negative half, so it's supposed to be 1 minus minus. Do you see that? Okay, I made the error deliberately so because this is a negative half. So there in the comment section, no, you're not dizzy, Lwandle, you are 100% correct there with the denominator. Okay, 1 minus, remember the r is negative half. The formula is 1 minus r. Okay, 1 minus r. So if we have 1 over 1 minus minus half, okay, please be very, very vigilant there. 1 minus minus half, that's 1 plus half. So that's 2 plus 1, which is 3 over 2. So it's 1 over 3 over 2, which then is equal to what, guys? 1 divided, so that's times 2 over 3, which basically gives you 2 over 3. So Lwandle, you're not dizzy. Lwandle, you are actually with everything. You are good, right? But now you are making yourself dizzy because I made you dizzy, and therefore you are becoming dizzy, but you were not dizzy, but you are 100% spot on. Yeah, so Lwandle was spot on there, guys. Because remember, the formula already has a negative sign. Which formula? This formula. Okay. A1 minus r. There's already a negative sign there. So if you are going to substitute 1 minus minus half, the negative times the negative becomes a positive. 1 over 1 plus half. Okay, so Lwandle, you were spot on. Okay, very much so. You just did not have the courage to stand your ground. 1 times 2 over 3, which is 2 over 3. That's sum to infinity. You were right. Okay, I was wrong. I just needed someone to have the courage to stand for what they knew is right, because sometimes learners tend to depend more on the teacher than they depend on themselves, and they rely on their own mathematical affluence. So we need to cut that. Okay. Will this infinite series converge? Okay, yeah, guys, we're gonna do more complex things tomorrow, but for now another time. For now, I just want to get the concept. That's why you guys are seeing me do simple basic stuff. That is the whole point. When you teach something at the beginning, it needs to first start where it's basic, so that the concept can actually find its way into your mind and heart. Then when the concept is settled in, are you going to see, I will unleash things on you. Then you'll see, if the concept has really been grasped. Okay, given, will this infinite series converge? Okay, what makes a series converge? Give a reason for your answer. That's what they say. Give a reason for the answer. So the question is, will this series converge? That's the question. Will it? Okay. What do we know we ought to happen if a series is to converge? Will this series converge? Why are you saying yes? I agree with you, it's yes, but I need a reason. The reason needs to be there. Okay. Remember the condition that needs to be there as far as R is concerned? Yes, R must be between -1 and 1 in order for a series to converge. So let's check what the value of R is. R is equal to T2 divided by T1. So we have half divided by 1. Half divided by 1 is half. What do you see in our R value? Okay, let's confirm it again with T3 divided by T2 so that we are not lost. 1/4 times 2/1. That also gives us a half. Okay, remember dividing 1/4 and 1/2 means multiplying 1/4 with 2/1. That's also half. So our constant ratio is R, which is half. Okay, so as R is greater than -1 but less than 1, this is a convergent series. Okay, I got R is equal to half, and my reason is because R is greater than -1 but less than 1. So that means it's a convergent series, no doubt about it. The last question that is being asked: determine the sum to infinity. So can we determine the sum to infinity for this particular series? Yes, indeed, because it is a convergent series. How did we establish it's a convergent series? It's because the value of R, the constant ratio, is between -1 and 1. R is greater than -1 but less than 1. So sum to infinity, you guys can calculate that for me, and then I will call it a night. You guys have been really, really amazing, to be honest. I commend you, all of you. Okay, no ways. 1:30 on a Christmas morning, and these kids are here. You guys are truly a phenomenal group, that's for sure. I take my hat off to you. I'm impressed, big time. Okay, Lwandle gets 2, Elihle gets 2. Okay, so we are getting 2s, which is great. Right, guys, please, this foundation of conceptual understanding, please don't lose it. Okay, please don't lose this. I have plowed, I have sowed. It would be so heartbreaking if you guys can basically meet me at another time, in another life, and then I have the same entities that were here. You guys were the ones that, resisted all the detractors. There were people that came in here and they were saying a lot of things, but you guys stayed the course. You are like the faithful few. If Jesus had his 12 disciples, then I have my followers here, that's for sure. And these are the people I would basically go to war with, against the enemy, if you know what I mean. Because you guys are reliable, you are faithful, you are reliable, you are valid, valid people, trustworthy. These are the people you would take to anything. So thank you so much for being so just being great sports. And your presence means so much more. We got to 30.7k likes. Thank you so much for that. That was appreciated. The gifts as well that came in there. Lwandle, thank you so much, bro. And all the others that I basically did not see or acknowledge. Nolu, amazing. You are amazing. That's for sure. You stayed indeed. So S infinity, we definitely, yes, it is what you guys have said it is. It is 2. A first term is 1. 1 minus R. R is half. It is positive, so I can just substitute it as it is. Then 1/2, which is the same thing as 1/2/1, which is 2. That's sum to infinity. Simplified, simple, and straightforward. Guys, this was basic. We will take it up a notch in our next few live sessions when we do more exam type and more challenging questions, but the basics at least are settled. We understand, for instance, what makes us to be able to use sum to infinity. It is when a series is convergent. How do we establish if it's convergent? By checking its constant ratio and seeing if the value of r is between -1 and 1. That's the surest and quickest way to establish if a series is convergent. Okay, we did a few problems where we were required to apply convergent series. Okay, and really and truly, that was a buckload of fun. Maybe it would be wrong for me if I did not end on this note, and maybe just as a concluding note. I'm sorry guys, I know I did say that that last one was the last one, but I think it would be wrong if I didn't end on this note. Remember, we said this is for the last, and we said this is the first, the substitution. So, well, in this problem, we can go ahead and substitute the first, substitute the next number, substitute the other next number. All right, so that we have at least what? The first three terms. So we have 8 2 over 3 to the power 0 plus 8 2 to the 2 over 3 plus 8 2 over 3 raised to the power 2. So when you write the terms, guys, okay, these are the terms, but for what type of sequence? It's a geometric series, right? But what type of geometric series is this? We have as our last infinity, and guys, substituting infinity, obviously that's something, you know, it's not finite. It means that we have an infinite series. So that is why we are going to obviously apply sum to infinity, because there's an infinite sign at the top, not a number that is finite. Does that make sense? So then from this, we are going to have to find what? A, and then find r, so that we can then substitute there at the bottom for 1 minus r. Our a value, okay, is obviously going to be what? Here, 2 over 3 to the power 0 will leave us with 8. So that means our a value is 8. Then we just use this to calculate the value of r. So we take the second term divided by the first term. That will give us a constant ratio of 2 over 3 if you do the maths. Okay, because that's 8. This is going to be 8 2 over 3. So if we take this and divide it by that, the 8 and the 8 will cancel. We are going to be left with 2 over 3. Okay. Then ultimately, we get 8 over 1 over 3, which leaves us with an answer of sum to infinity, which is 24. Okay, I thought I should just end on this note, guys, at least. All right. Yeah, so we will definitely pick up things from this point when I come back on, whether that be tomorrow or later on today. I don't know, guys, for sure. I may not be able to do later on today. So enjoy your guys' Christmas with your family. Enjoy yourselves. Have fun and all of that stuff. And please, guys, don't feel bad if you can't join my live. Let's say, for instance, you are really busy and you are doing stuff, and me, I'm live. Don't worry. If you can't join, you can't join. If you can join, then you can join. If you miss anything, the YouTube channel is always there. You can always hop on there and you can check out whatever I did. Unfortunately, with that poor quality that it has, but that's just raw videos, guys, that I upload as they are. Okay. Thank you so much. I really appreciate you. I hope you guys receive this lesson with the heart that it's meant to be extended towards you. Thank you so much. I really appreciate you. Let me love and leave you. Have a beautiful, amazing night, and please do enjoy your Christmas with your guys' families and with relatives or whoever it is you guys are spending your day with. Okay, I'm glad I could spend a bit of that time with you guys and spend it doing maths. Thank you, and much love to you all. Cheers, cheerio, and have a good one. I wish you a Merry Christmas, and of course, we will extend Happy New Year vibes when New Year vibes actually rock around. Okay, danko. Thank you. End that thing, bro. Kamo, you are funny. You're welcome, Elisha. Really welcome, buddy. Really welcome there. End that thing, brado. Kamo, you're funny, bro. You're funny as something else.